All right, so in this video, I'm going to step you through the first bit of code in producing our values in our first hidden layer. If you didn't get a chance to watch the previous video, which I went over the overview of everything we're going to do in this series, you might want to take a look. I will sometimes refer back to some things I talked about in that. Otherwise, though, let's go ahead and start programming. All right, so I had said that we're going to work with some kind of dummy data, some mock-up data for this first neural network, and it's going to be very simple. These are actually our inputs, and as you see, there's it says batch 1 and batch 2. And that is very traditional, that when you send things through a neural network, you have batches of data that you send through. Again, I'll go back here. This batch, when we work with these numbers here, we'll have thousands. I'll probably send like 1,000 through, but like you can even have more than that. Thousands of batches as part of your inputs. And the way that works is like you calculate you make all your calculations on your first batch, then you do it on the second, and you keep going, and then you produce neurons for the next layer based on those calculations. But for all intents and purposes, this batch doesn't really know that this one exists, and it doesn't have to. It's just for you, the more data you send through, the better you're going to be able to train your network. And that's the whole point, is to get it trained well, and then you send it through with your actual test data. So this is a very simplified example. We're just going to have 3 values here and 2 batches in our input data. And so you see here that this is the first batch's data in our input, and our next layer is just going to have 3 as well, and that's arbitrary, but I just figured I'd keep it the same, keep it very simple. This could very well be, that doesn't have to, as I already determined, or as I already discussed, this does not have to match the amount in this layer. In fact, it's usually different. Okay, so enough on that. I'm trying to make sure I cover everything and explain these in simple terms. I'm kind of assuming that you do not have any experience as you go ahead and do this, so that's how I'm going to approach this. And so, as I said, I'm going to give you the data. And so traditionally, we would produce weights that would be random numbers between -1 and 1, but I'm going to give you the weights this time through, and so here they are here. I will share all the code. If you want to start typing this in, that's fine, but I will. You can look in the description. There'll be a GitHub link to the code, and so the weights and the biases are important. We're going to use them to perform some calculations on our input data. And so I'm just giving you some weights that are just kind of arbitrary here. But like I said, they would regularly be random numbers. The biases, though, typically are set at the beginning of your neural network to 1. And that's what we'll do here, and that's what we will do again when we do it with the actual digits, the real data that we're going to mess around with. And so and so just another thing about the weights. The weights should have a row for each neuron in our hidden layer. And so I had said we're going to have 3 neurons in our hidden layer. And so there's a row for each of them. The weights should also have a column for each value in our input data. That just happens to be 3 as well. And so we have 3 columns. Okay. And so here's the values we're going to use. And as I said, the biases will be set to 1. There will be a bias for each neuron in our hidden layer, so there will be 3 of them as well. And so, yeah, so when I'm creating this, I'm going to keep this simple. We're going to have a runner class that's going to have a main method. We will declare our inputs there, as I did here. This is basically the start of our runner class. And then we're going to have what I've called a neural layer class. That's going to have weights and biases. And those are class variables. And there's a constructor method that takes in the number of inputs, which is 3, the number of neurons, which will be in our next layer, which will also be 3. And I'll show you how I set up that in the runner class. Don't worry about this set weights. That was, I'll show you that calls this method here. And you see how we are just assigning the weights that I showed you to our weights class variable here. And then we also set our bias array to equal 1, each value in there. And so, yeah, so our weights are just a multi-dimensional array of 3 rows and 3 columns. Let's see, anything else I need to talk? All right, so the only thing that gets slightly complicated in this first part is what's called the dot product function. And what the dot product function, this is kind of an example. We have our 3 neurons, and we are going to take the inputs and multiply them by the weights in that first row, and then sum the results, and then add our bias to it. And that becomes our first neuron in our hidden layer. That's going to actually have this screen, I think, does a better job of kind of explaining what's going on here. So this is basically what's going to happen in that dot product. And anyone who's kind of worked with linear algebra is probably familiar with the dot product function. So this might be overkill, but I'm just going to assume that you didn't know how it works. And so here's how it works. So you take your first batch, and you're going to multiply these values together. So 0.1 times 0.1, 0.2 times 0.3, 0.7 times 0.4, and then you're going to add each of them together. And this is kind of an example of what that looks like here. You're adding them together. You get this value of 0.35, and then we add 1 to that, so you get 1.35. That will be your first neuron in the hidden layer for the first batch of values. So if we're going back to here, that's going to be this one right here, 1.35. Okay, and then you do the same calculation. You basically drop down to the next row, and then you do the whole process over again. 0.1 times 0.2, 0.2 times 0.2, get the value, and then whatever the result is, put right here. All right, hopefully that makes sense. And then we're going to have an output variable that's going to be a multi-dimensional array that's going to save all this. I'll show you that in a second when I show you the code, the full code. And then the last thing you would do is you drop down to this row, your next batch, and then produce the neurons for that batch, the 3 neurons that we need to, and you would multiply these together. Hopefully that makes sense. Let's take a quick look at the code before I end this session. So, so here we go. We have our inputs that I had already showed you. I have my neural layer class that I kind of already showed you this much at least. But let me, and I should actually no, I don't need that because I do it here. So I create an object of the neural layer class, and then I call my set weights to make sure my weights are set to these values. And then we go ahead, and this is the multi-dimensional array I was talking about that we're going to save our outputs. And so I use my object, and I call this forward function, which I haven't talked about this yet, but this is all this does is it takes in the inputs and then combines that with our weights and biases to call this the dot product function, which I just called dot, that I again save to an output. And so here's the dot product function. Let's just kind of look at this. We got our inputs, our weights, and our bias. And we're going to go through, and for each batch of inputs, we're going to go ahead and do that dot product calculation that I talked about, where we're going to add up, we're going to sum up the product of each of the inputs times the weights, right? And then after we sum that up, they're doing the plus equals here, then we add the bias, which is going to be 1. So the first time through, I should get that 1.35 that I was talking about. You can ignore this for now. That's something we'll look at later, perhaps. And then we just return the output. So this is going to do that for each batch. We'll get that calculation here. So hopefully this is not too complicated. I think the dot product is the only thing that's semi-complicated, but you see that we're going to go through each batch, and we'll look at each of the rows of the weights, and we're going to add them to our inputs. And so that's what's going on here. I'll share all this code with you, but just so you can see it, let's go ahead and run this. And you see we get that 1.35. I didn't mention this, but in my runner class, I actually have this function here that I call, that just prints out our output, multi-dimensional array, so that I can see that the values are actually what I wanted them to be. I'm going to share all this code with you, but you should try to do this on your own as well, or make sure you understand it. Please let me know if you have any questions. I hope I've stepped through this in a manner that was easy enough to understand. Yeah, please post any questions. And in my next videos, just so you know, just to give you a heads up, that we're not done. We've actually still need to do something else to complete that first hidden layer. And that, what I'll show you in the next video, is we have to run our values that we just got, that 1.35 and the other values, through an activation function. And then we will have completed our first hidden value. All right. I hope you enjoyed that. Thank you.